According to Wikipedia, the United States is one of only 3 countries in the world that doesn't use the metric system as their official system of weights and measures. Instead, we use the English system and measure things in miles and gallons and feet and quarts and things like that. In science, however, even the United States uses the metric system as their system of measure. This is important because scientists all over the world share their findings with each other, and to do that they use the metric system. The metric system is simple because it is based on powers of 10. For example, if you were going to convert in the English system, you would have to memorize or look up the conversion factors that get you from one unit to another. In the metric system, all you have to do is slide the decimal, which is what we're going to be learning how to do today. First, we need to understand the difference between a unit and a prefix. There are many metric units that scientists use for reporting measurement. These are the ones that I will expect you to know for your quiz. Distance is measured in meters, which is abbreviated with a lowercase m. Mass is measured in grams, which is abbreviated with the lowercase g. Energy is measured in joules, which is abbreviated with a capital J. Time is measured in seconds, which is abbreviated with a small s. Volume is measured in liters, which is abbreviated with a capital L. Power is measured in watts, which is abbreviated with a capital W. Electric current is measured in amperes, which we also call amps, and it's abbreviated with a capital A. And then pressure is measured in pascals, which is abbreviated with a capital P and a lowercase a. These letters that you see over here are the ones that will plug in for the unit portion of the metric conversion scale. You will see all these base units by themselves, but you will also see them with a metric prefix. Just like a prefix to a word, the metric prefix goes before the base unit. There are 6 basic metric prefixes: kilo, hecto, deca, deci, centi, and milli. The base unit goes in right here. So under base unit you could find M for meters, G for grams, J for joules, S for seconds, and so on with all of the base units that we discussed. Then what these metric prefixes tell us is how many times bigger or smaller the measurement is than the base unit. For example, a decameter, which is abbreviated DAM, is 10 times bigger than a meter. A decimeter, which is abbreviated DM, is 10 times smaller than a meter. And then if we go to centi, a centimeter is 100 times smaller than a meter, and a millimeter, which is abbreviated MM, is 1,000 times smaller than a meter. So as you go to the right, each time you get 10 times smaller, and as you go to the left, each time you get 10 times bigger. So a kilometer is 1,000 times bigger than a meter. Once you get to the portion where you have these dotted lines, that means that instead of moving the decimal place 1 place to the right, you're going to have to move it 3. So from milli to micro, I would have to move a decimal place 3 times, which tells me that a micrometer is 1,000 times as small as a millimeter. And then to go from micro to nano, you'd also have to move the decimal place 3 times, which tells me that a nanometer, or nanogram, is 1,000 times smaller than a micrometer, or a microgram. The same works over here on the bigger side. 1 megajoule is 1,000 times bigger than a kilojoule. We can put all of the prefixes together with all of the units. So we could say gigagrams, megajoules, kiloseconds, hectoseconds, decagrams, joules. Any of these can go with any of these, so we can make many, many combinations of metric measurements. Here are the steps that we are going to use for converting with metric prefixes. First, you're going to start at the prefix of the unit that has the given number. Then you will count the number of times you must move the decimal to get to the new prefix, paying attention to whether you're moving to the right or the left. And then finally, you'll move the decimal the correct number of times in the correct direction. Note, if there is no decimal, it is assumed that the decimal is after the number. And then finally, you'll write the answer with the correct units. Now we're going to try a couple of these. The first question says, how many decigrams are in a decagram? Well, this one's a little bit tricky because it doesn't show a number, but if it says a decagram, that means 1 decagram. So our given number is with deca, so we are starting at the prefix deca. We want to get to decigrams, so we're going to the prefix deci. So we have to move the decimal place 1, 2 places to the right. So we start with 1, and the 1 doesn't have a decimal showing, so we assume it's right after the number. So, and then we move the decimal place 2 to the right and fill in with zeros. So our answer is 100, and then we have to make sure we put our correct units on. It's asking for how many decigrams, so we write 100 decigrams. All right, the second one says how many nm, which stands for nanometers, are in 0.005 decimeters. This time we are starting at deci because it has the given with it, and we are going to nano. So we'll go 1, 2 places to the right, then we need to go 3 more to get from milli to micro, and 3 more to get from micro to nano. We have to go 3 because these dotted lines indicate that it's a power of 1,000 between those two prefixes. So we went from deci 1, 2, 3, 4, 5, 6, 7, 8 places to the right to get to nano. We began with 0.005, and we want to go 8 places to the right. So we go 1, 2, 3, 4, 5, 6, 7, 8. We fill in with zeros. So we end up with 500,000 as our answer, and then we need to check our units. How many nanometers? So we put nanometers as our unit. And there's our correct answer. All right, this one says, how many kilometers are in 18.5 centimeters? Our given value is with centimeters, so we're starting at the prefix centi. We want to go to kilometers, which is the prefix kilo, so we're going to be moving to the left. We move 1, 2, 3, 4, 5 places to the left. We begin with 18.5 and move 1, 2, 3, 4, 5, put our decimal down, and we end up with 0.000185, and our units are kilometers. All right, the next one says convert 145.7 mJ, which is milli, to nanojoules. So we're going to go from milli to micro, 1, 2, 3, from micro to nano, 1, 2, 3. So that's a total of 6. So we start with 145.7. Here we were moving to the right, so we need to go 6 to the right. So we go 1, 2, 3, 4, 5, 6. Add in 5 zeros. We have a comma, comma. We end up with 145,700. And then we check our units. We're going from milli to nano, so we went nanojoules to be our units. Now if you'll notice, this problem has a lot of zeros that we had to write out, and sometimes they can get even more zeros than that. So here in a little bit we're going to learn how we can use scientific notation to help us not have to write those numbers out quite as long. Okay, here are a couple more practice problems. We want to convert 34 capital M, L. Capital M is mega. So I'm going to start at mega liters, and we want to go to liters, which is the unit. I'm not sure if I said this before, but among the unit is going to be liters and grams and meters and seconds and joules and all those things that are just units. So liters is here at units. So to go from mega to liters, I'm going to go 1, 2, 3, 4, 5, 6 places to the right. I start with 34 and I go 6 to the right. 1, 2, 3, 4, 5, 6. 0, 0, 0, 0, 0, 0. So I get 34 million, and my units would be liters. Now I want to show you another way that you can write that number. You could also write 3.4 times 10 to the, and see how many decimal places there are. 1, 2, 3, 4, 5, 6, 7. 10 to the 7th liters. Either one of those would be correct. Sometimes it just saves us time to write things in scientific notation. All right, then the next one says convert 1.8 micrometers. Now micro is a kind of interesting looking unit. It's the Greek letter mu. It looks kind of like that, kind of like a combination of a funny M and a U. So you do want to be careful with the metric prefixes because there's milli, which is a lowercase m, there's mega, which is a capital M, and then there's micro, which is the Greek letter mu. All of them look kind of the same if you aren't careful about how you write things. So we are going from 1.8 micrometers to kilometers. We start at micro, and we're going to go to kilo, which is over here. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. So we had to go 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. So starting with 1.8, we move to the left 8, 9 places. Place our decimal and fill in with zeros. And we get 0.00000000018. We check our units and see that they should be kilometers. So there's your answer for that one. On these last two, we're going to use scientific notation and see how that works when you convert with things in scientific notation. So for this one, it says convert 4.75 times 10 to the 18th decawatts to gigawatts. First of all, we know we're going to start at deca, which is here, because that's the one that has the given number with it. And we're going to go to giga. Giga is over here. So we need to move our decimal place 1, 2, 3, 4, 5, 6, 7, 8 to the left. When you start with 4.75 times 10 to the 18th, in order to move to the left, you can just subtract from the exponent the number of places you went. So since we went to the left, we are going to subtract 8 from 18. And we end up with 4.75 times 10 to the 10th. And then our unit would be gigawatts. So that is your correct answer. And if you want to see that that really does work, go ahead and do it the long way. Write 4.75 times 10 to the 18th out and then move the decimal place 8 to the left, and you will see that you end up with a number that can be written in scientific notation as 4.75 times 10 to the 10th. It just saves us a lot of time and pencil lead to not write all the zeros. All right, then the next one, 2.4 times 10 to the negative 24th killiamps to centiamps. Killi is here. We're going to go from kilo to centi. So we'll go 1, 2, 3, 4, 5 places to the right. Notice I don't have to move 3 for any of those because I never am outside of the ones that have the dotted lines. So 1, 2, 3, 4, 5 places to the right, starting with 2.4 times 10 to the negative 24th. Now, because we are moving to the right, we're going to add to the exponents for the number of places we moved. So we're going to add a 5. And negative 24 plus 5 gives us a negative 19. So we would end up with 2.4 times 10 to the negative 19th centiamps, because that's what we're trying to find as our correct answer.